Good morning. Good morning. I Ishwari welcome you all and thank you for joining us today for Faculty Development Program Day 4 Session 1 on Blockchain. Today we have participants from Gujarat, Madhya Pradesh, Chhattisgarh, Rajasthan, Karnataka and more in all 57 participants. Today we are privileged to have Dr. Saurav Kanti Addya, Assistant Professor, Department of Computer Science and Engineering, NITK Surathkal with us today. Sir is an assistant professor in Department of Computer Science and Engineering at National Institute of Technology, Karnataka, Surathkal, India. Sir received his PhD in Department of Computer Science and Engineering from the National Institute of Technology, Rourkela. And he was a postdoctoral fellow in Department of Computer Science and Engineering, developing efficient solutions and addressing different aspects of cloud-based systems, serverless computing, and fog edge. He has been working on these areas for over 8 years, which includes the entire duration of his PhD, which primarily focused on developing efficient placement and pricing strategies for single and multi-cloud architectures. Currently, his research team is actively involved in developing solutions for cloud and serverless paradigms. Apart from this, Sir has publications in several top reputed conferences such as IEEE Infocom Core A SAR, IEEE Cloud Core B, IEEE SCC Core A, IEEE. At the time, let's start with the session.
Yeah, thank you for your brief introduction. So first of all, I need to thank you, the organizers of thing, to invite me for this particular talk. So let me share my screen first. Hello.
Yes, sir.
Okay.
Yes, sir. Yes, sir. It's visible.
So thank you for inviting me. So today I will briefly explain this concept called blockchain and how you will implement in other technology or other paradigm. So basically how you going to adopt this one thing, other thing. So generally it is required to intercross technologies platform when we need to adopt some other technology or concept to in another technology or concept, and then we need to implement it. So my research area is distributed computing, especially cloud, the serverless, edge, IoT, blockchain. So these are the few concepts I am teaching and I am researching several times, maybe more than 8 to 9 years.
Okay.
Hello. Okay, so next 1.5 hour, I will talk first about little bit about blockchain. I'm assuming that the preliminary concept of blockchain, all the participants or audience have. If in between you have any question, you can raise your hand or you can interrupt me and then we can discuss. So more or less, if you have any kind of questions and other thing at the end also you can ask. So the topic, so as she mentioned, I am from in National Institute of Technology, Karnataka, Suratkal. So I am heading one lab called Cloud and Smart System Services Lab. Before starting that, so this is our institute, main building of the institute. It's a beautiful campus of coastal Karnataka. Side by we have Arabian Sea, just we have, and for your information that we have only government institute in India who have their own beach. So we have our own beach. This is our department, the computer science department. Some of the things we have in our campus like National Bird, and this is the view, Arabian Sea's view from our department. So this particular slide I want to keep because as it is a virtual presentation, I want to feel you that from where I am belonging or where I am working. Anyway, so we are contributing different things, different research area in our department, starting from machine learning, deep learning, speech processing, different verticals of networking, and distributed computing, for example, cloud, blockchain, all those things. And also another group working on the different aspect of computer security. Coming back to today's outline, so today we will first discuss little bit concept of blockchain, which is required to understand this thing. Then we will talk about design philosophy of this thing, and then we will see how this concept of blockchain will help the different cloud service provider to tackle certain situation. So I will show you how we have configured this one as a test bed in the lab, and all configurations, other thing we will show. So if you have knowledge of blockchain and the cloud, then this particular talk will be interesting for you. But if you don't have also, you don't worry. I will going to explain in detail each and every slide. If you have any question, you can ask me. I am sure that after completion of this particular talk, you will be going to have lots of question on your in your mind when you will go back to your home. So basically, as I told, I will talk about blockchain first, and I will adopt this blockchain, the mapping between one technology to another concept to cloud, and finally we will do something the model which have cloud with blockchain. So how we can implement blockchain in other service delivery model, that is the objective of the talk. So I choose this topic specially because generally people talk about in depth of the technology, but when I asked organizers that what you want, so they told that some applications. So I thought that we can discuss this one. So it will be interesting for you to motivate you to adopt some technology in other concept and the procedure how to do. Now come as first thing, I need to ask what is blockchain then? So if want to know, so my first question is to a audience, what is blockchain and whether it is a currency or a technology. Means generally when we are talking about blockchain, then first thing comes to our mind is Bitcoin, right? So what is Bitcoin then? What are the difference between these two terms called blockchain and the Bitcoin? So if anybody have an answer on this, so please unmute yourself and tell me what is your thought on this particular question. Or if I more precisely ask you that is Bitcoin is equal to blockchain? Is it? So anybody, if you have any question, if you have any answer for this or any thought on that, please unmute yourself and tell. So is the both the terms are synonym to each other, or one is a subset of another one? What? Okay, no issue. Let me explain this thing. Yes, Bitcoin is not equal to blockchain. So blockchain is different thing, Bitcoin is different thing. Yes, they both this term have some intersection point where it is overlapping some of the things that we will explain. So what is Bitcoin first? The Bitcoin is basically this Bitcoin is basically your currency. So as it is a currency, it have some its property which is have all the other currencies have. But on the other hand, blockchain is not a currency or something. Blockchain is a technology. So as it is a technology, it have its own properties like blocks, network, distributed shared ledger, cryptography, consensus, and smart contract. So these are the few of the elements which we have in our blockchain. Now, if we compare these two between Bitcoin and blockchain, so you can see that this blockchain part is heavier than this Bitcoin part. Because this blockchain part have so many things or elements where the Bitcoin is only the currency. So we can say that blockchain is a technology where Bitcoin is an application which based on the blockchain concept. Or more precisely, I can say that Bitcoin is a one type of blockchain which adopted in the Bitcoin concept or to develop the Bitcoin network. If I tell in a very simplified way, then if you go back in more detail, so our main discussion point is not Bitcoin, our discussion point is blockchain. Why I kept this slide? Because whenever I went to any talk or any discussion, people have this misconcept that Bitcoin and blockchains are same or they are synonym to each other or Bitcoin is more heavier than the blockchain. But no, we should talk about the technology, not about the application. If you know technology well, then you can go to any application or you can implement that technology in any application. Here, Bitcoin is one of that application. And today we will discuss this thing, this blockchain to another application, which is cloud or our this blockchain with cloud, whatever we will discuss today. So that's why this particular slide is important to understand or set the context of today's discussion. Yes, please unmute yourself and tell Raj. Hello. Okay, I think by mistake he is. So come back. So we will talk about blockchain. So what is blockchain then? I might have you people know these things, but let me introduce blockchain in some precise way. Yeah, Gaurav, do you have any question or? Okay, so what is blockchain then? Blockchain is basically multiple authoritative domain. Blockchain have multiple authoritative domain. Here you can see there are person or the user, they each have their own characteristics or own authority on their domain. And they are different, distinct people or distinct system. Now, the next thing is they do not trust each other. You can see by this particular diagram or the figure, it is very funny, but you can see that they don't want to trust each other. Basically, they are competitor between each other. Okay, now, but they want to collaborate between each other for some mutual benefit. Means, for example, there are three people in a market or 3-4 shops in the market who have same type of service, let's say grocery shop or the taxi service or same type of service in your market, they want to collaborate for some mutual benefit, but basically they are competitor to each other and they want to gain some profit on the other person, on the top of other person. And here the issue starts. So generally, the issue is they have their own authority in their domain. They are basically different, distinct entities. They do not trust each other, but they want to collaborate for some mutual benefit. So see, all these points are contradicting generally. If they are friends, then all those issues are not there. There should be some trust. They can always collaborate, and their authority also can be imposed on others. But in the practice, it is not happening generally. So we need some solution, right, for this particular authoritative domain where no trust, but they want to collaborate. And the solution is this one. Blockchain can give this solution, and the solution is a trustless, decentralized platform. How? So that is our target. If we are able to build that one, and that basically blockchain gives us for. So this is a scenario where you can implement. So if you have this kind of scenario or this kind of system where multiple authoritative domain, no trust, but can collaborate or want to collaborate, then blockchain can be a exact solution or possible solution. So then what is blockchain then? If you go to the definition of the blockchain, then it can be a decentralized computation and information sharing platform. See, it's a platform, right? So we are talking about technology, right? So that's why it's a computation and information sharing platform that enables multiple authoritative domain who do not trust each other to cooperate, coordinate, and collaborate in a rational decision-making process. So please note these 3 words: rational decision-making process. Understood? I think things will be more clear if you go in depth. Now, it is essentially a decentralized database with strong consistency support. Every node maintains a local copy of the blockchain data or global data. So whatever the global data we have, every node want to maintain its local copy. So that means virtually there is a global database, and that database has been shared to all other people as their local copy. So basically there is no global data. This global data is basically logically global data, but actually it's a view. It's a view of the local copy of each people. And this making this global data, there is lots of mechanism to create it. Okay, so the system ensures consistency among the local copies. The local copies at every node is identical. The local copies are always updated based on the global information. And this global information happening with the consensus only. So this consensus will give you the democratic feel in the system. So first we need to understand this this type of system don't have any central authority to control all other domain. Generally, in client-server architecture, there is a centralized server, other nodes are the slave. It's a master-slave kind of thing. They are slave to the centralized server, and the server have all the logics and other thing, and they are basically controlling. But here, things are not like that. So everybody have their authority to do their own job, but during collaboration, they has to meet the consensus. Consensus means maximum people agreed on the thing what they are going to be proposed or going to be executed. So that consensus have different algorithm in blockchain, typical blockchain concept. There are n number of consensus algorithm, how you will make the consensus, and there are different issues like malicious node and other thing. So here different research vertical will start to design appropriate consensus algorithm because there is no centralized authority. So if we go further, so blockchain work like a public ledger, a database of historical information. Some of the important aspect: protocol for commitment, ensure that every valid transaction from the clients are committed and included into the blockchain in the finite time. So I have highlighted this particular term called finite time. So in my entire slide, you can see there are many terms are highlighted in different color or bold or italic. So I want to give some stress. On this particular term, finite time. So when this commitment happen, or if you do any transaction among your peers, means in the network of different nodes or peers, we can say peers, then there should be all those transactions should happen in some finite time, predefined finite time. I can say predefined finite time. If a transaction will take infinite number of time or expect doing something on expected beyond the time limit, then there may be a chance of malicious injection. So that malicious kind of inputs or inject that malicious kind of information will hamper or the ultimate to reach the consensus, or it will block to reach the consensus of the system. So that's why protocol for commitment should happen within the finite time. So it looks like you have committed to your friend that I will do a job for you with tomorrow. Or so if you not do that thing, that means you fail to keep your commitment. So here also, if some transactions happen between two peers, then it should happen within the finite defined time. Then the consensus, if the consensus ensures that local copies are consistent and updated. So that means if there are 100 users or 100 peers in your network, somebody did some transaction with other person, but rest of the people should update what happened, though they are not involved in that particular transaction, but they should know what happening in that with the global view, or what is happening in other part of the network. So that is basically your consensus. Then security. Security is also an important, because whatever data we have, we need to be a tamper proof. That is a phenomenon concept, or it's a one of the main, one of the important concept in blockchain, and that's why blockchain is so popular in terms of security. Anything you have wrote in a block and that block has been added into the chain, you cannot edit, delete, or modify it. It is a totally tamper-proof. That is a first step or first major thing what blockchain gives us. That's why it is a fully secure. You cannot tamper it. You can modify that data and add as a new block in the chain, but you cannot. So it is something like that. If you know the blockchain concept, then you have such chain of blocks, right? You have chain of blocks, and this is a chain of blocks, and you have did some transaction here. Let's say your current Bitcoin value is, let's say, 5 Bitcoin, and it is added into the blockchain. Now somebody wants to tamper this value 5, and he wants to reduce or increase this value. Like in your bank passbook, some money you have in a digital form, but somebody wants to tamper on that data. That is data, right? So this particular data, even if somebody able to tamper, they cannot tamper within this block. This 5 will remain there until this block will exist. But what he can do, he can tamper that data in some form, and he can add as a new block. So whenever the mining process happen, you will always get that in that particular version you have of Bitcoin 5. So that is a tamper proof. And for maintaining this tamper proof, blockchain use different concept called marketry, different kind of hashing, different kind of SHA kind of things and other things. So note that the clients may act maliciously or can be compromised. It happened, but data cannot be changed. Finally, privacy and authenticity. The data or the transactions to various clients, privacy, authenticity need to be ensured. Otherwise, people will not join your service, right? If you are providing some blockchain service, people will not join your service until and unless you are providing some security, privacy, or authenticity, right? So it's a network topology. So we have some traditional network. So in our traditional network, inefficient, expensive, error sensitive, different vulnerable kind of things happening. On the other hand, we have distributed network kind of topology where consistency, efficiency, security, and resilience will be ensured or generally ensured. In that part, if it is a traditional network, it's a traditional centralized server and there are different clients. So the issue is if this particular server will compromise, then anything can happen in this network. So the things or the transactions will happen in this network, it will not be proper or expected one. And there may be another problem like this particular server may bias towards certain number of users. So whatever profit and other thing will come, they will first share with them and these people will under darkness. So in that sense, this kind of network will always useful generally. Why? Because every nodes are peer of other nodes. So if there are n number of nodes in your network, the number of links or degree of any node will be n-1. So, but creating this kind of network is always costly. Creating this kind of network is less costly. But as it is less costly, so it should have some more technological problem, whereas this is a more costly. So building this one is difficult, but if you are able to build this kind of network, then it will be more safe. So some key concept of blockchain, we'll go back. So it is basically give you the distributed shared ledger. It is basically give you the cryptographic different hash. It will give you the consensus among different parties or nodes or peers. It will give you finally the smart contract. Okay, so I will tell you just some time on smart contract. What do you mean by smart contract then? The smart contract is the logic or the flow, how everything will happen, how consensus will take place, what is the mechanism to meet the consensus, how node will be joined in the network, what is the mining process of the network or that particular blockchain network, how to detect the malicious node, what will be the finite time period of one transaction. Everything will define in the smart contract. So basically, smart contract is your head, or it is basically the main algorithm or logic where the entire network should be controlled or written in some programming language. So different tools have used different kind of programming language to write their smart contract. So I think in short, I can say this smart contract is everything, how network will work, how logic will flow, what mechanism or way they will do certain things, everything will be in the smart contract. Or if you want to design such a system or network, you have to write your own smart contract. So some of the key concepts: group of replicated logs or database nodes, already told. Transactions distributed in the blocks, in different blocks. All nodes hold all transactions. That means local copy of global data. Parties identified with public key. Accessibility of transactions depending on blockchain implementation. Resilient for failure of one or more nodes. So failure handling also can be possible in the blockchain network. Group of nodes operate tamper-proof. So tamper-proof blocks can be possible. So these are the some key component or key features of this particular technology. Now, if it is there, we can talk about type of blockchain. Generally, there are two types of blockchain. If you know, that is called public blockchain. So public blockchain are basically permissionless blockchain. In other words, people are saying instead of public blockchain, it is called permissionless blockchain. It's basically an open network. Anybody can join. Ethereum is the one of the tool with which you can implement public blockchain or permissionless blockchain. You can see these nodes are directly connected to other node or peers in this particular diagram. So basically there is nothing, anybody can join and anybody can leave the network. On the other hand, we have private network or private blockchain, or other word we can say it is permissioned blockchain. User has to permit by some authority or some credential you have. Hyperledger Fabric is one of the tools through which you can implement permission blockchain. If you see the diagram, there is a significant difference between these two diagrams, right? This one and this one. So if you see this, anybody cannot join. They have something called authentication or the credentials. So if they have authentication on credential, then only he or she can join in this network. On the other hand, public network, anybody can join in this network. There is nothing called authentication or credentials. So I will not go in depth. You can Google it. So my today's objective is what is this? So now I will see how this particular concept of blockchain we will implement in cloud. So that was our objective of this today's talk. So next half an hour, we will talk about this concept of cloud. What is the crisis or challenges we have? That's why what is the requirement to implement blockchain in the cloud? Why it is required? I am not forcefully implement this one in the cloud. There is a specific requirement. So that we need to see next half an hour. So by this time, so this 40 minutes what I have discussed so far, is there any question you can ask me, and then we can proceed the next section. Okay, I believe things are going good. So people don't have any question. We can take some questions at the end. So next thing is mapping this blockchain into the cloud. So this is our target. As I told earlier, we have a technology called blockchain. We have a technology called cloud, and these have some issues which can be handled by the concept of blockchain. And finally, we can get this kind of architecture. So decentralized cloud kind of architecture we can get. Let's see how we will get this one. So before coming this, we need to understand current market scenario. What is your application type current today's age or today's time? Generally, we are hosting or we are seeking service from any cloud service provider. For example, Amazon, AWS, EC2, Microsoft Azure, Google GCP, anything. So we are basically seeking service in a different form. There are different kind of service available. Now, if you see the current market trend or current application type, the applications are multi-tier in nature. So the moment I am saying it is multi-tier in nature, that means more than one servers are required to host one application. For example, here we have application 1 which need 2 servers, one web server, one database server. Application 2 need 3 servers, one web server, one application server, and 3 database servers. Application 3 need 4 servers, where one web server, 2 application servers, and 1 database server, and so on and so on and so forth. So generally, when you are hosting or deploying your application off premises, means on the cloud, basically you are asking the server to be hosted on different data center of the cloud. So in the cloud, the servers hosting means basically you are procuring different virtual machines, that is called VM, to be hosted in the data center. Right. So that means in terms of cloud, if I say my applications need 3 servers, that means basically I am asking for 3 VMs from the cloud service provider. So you need to understand the current application type or the system requirement. Okay, so that we understood that these VMs can be placed in the data center. But where these data centers are situated or where these data centers are basically placed. So these data centers are basically geo-distributed resources across the globe. So in the global plane, there are different data centers situated in different places in a geo-distributed manner. And this, the logical view is called cloud. So they are connected over internet or network, and the virtualized resources are realized through some concept called cloud. So you need to understand this cloud or those VMs which I need, let's say I need 4 VMs to be placed for my application. So those 4 VM can be placed in different places of this data center. Let's say this is a London data center, this is a Mumbai data center, this is a Sydney data center. And one service provider have, so I need, let's say 3 VMs. So these 3 VMs can be placed one here, and one here. Yes, anybody have anything? Somebody is saying something? Okay. So, we can place in different places. So basically they are geo-distributed on the planet. For your information, Google have 27 regions on the globe and 100 plus data centers on those 27 regions. All our data like YouTube video, all other things, what we are uploading each and every day, those are storing where? It is storing or executing basically. It is executing on the Google data centers. All those 100 plus data centers what Google have across the globe. Now, the problem, this is the scenario from one cloud service provider like Google GCP or Amazon AWS. Or it can be, so same thing is true for other cloud service provider like Azure. So in that case, some of the, so this Amazon, Google and Microsoft Azure, all are the big players in the market, cloud market. But there are certain cloud service provider who are not as big as all these 3-4 giant players. So they have their own infrastructure to be sell or rented to the user, but they are underflowing of the resource utilization. So what they can do in that sense, they can collaborate with other cloud service provider to getting their business. Here I can say you that, for example, there are 3 cloud taxi service provider in your city. One is very popular, who taxi service provider one, always he is getting some good business, always customers are coming to him, but other service providers are not getting that many customers. So whatever vehicle they have owned, they are not properly utilizing. So they are basically not running on the road. So what if they collaborate between each other? So the first service provider don't have enough vehicle to be given the service, or where other two have don't have customer to get use his or their infrastructure. So in that sense, if they collaborate between each other, so customer can come into service provider one, and service provider one can divert that customer. Okay, my friend have one vehicle that I can give you. So through customer one, customer two can rent his vehicle and he will get some benefit. And obviously customer one also gets some incentive from them. So this kind of collaborative marketplace always happening in entire business or e-commerce site or other things. So in that sense, one concept came called cloud federation. So this cloud federation is basically the collaboration among, it is basically the collaboration among different cloud service providers, whereby they agreed to mutually share their own resources for their overall benefits. So it is basically, there are 4, for this particular example, there are 4 cloud service providers who are in the cloud market, and they are basically want to collaborate for their mutual benefit. So motivation for federation, or you can call it multi-cloud architecture, it is basically sharing the computing resources, aggregation of unused resources from different service provider, bringing service closer to customer by maximize the geographical barrier, tackling data protection laws that require data to be stored within the country's boundary. So there are different motivations. So mostly in this cloud market, this kind of multi-cloud architecture or federations are mostly centralized. So there is a centralized broker who income or incoming. Also, what I discussed during the blockchain kind of thing, network, that this kind of network can have some certain issue. First issue is this particular broker or centralized platform can fail. So centralized failure will damage this entire ecosystem of this particular architecture. This person can be malicious to certain service provider, and those service provider can get more business compared to other in that particular architecture. So mostly the centralized approach are good. This particular person is not biased to anyone, or there is no attack on this particular people. So there are certain centralized broker, for example, these are the few example we have who are providing this kind of centralized federation kind of broker-based system. So user requests generally come from across the globe, and it comes to the broker, and broker will divert that incoming request to different users. Now, there are another kind of marketplace called centralized exchange. It is more or less similar to any e-commerce site like Flipkart or Amazon e-commerce site. So it is a marketplace where every seller come with their own product and they are selling. So like for example, if you want to buy a smartphone, that smartphone you logged into the Flipkart or Amazon e-commerce site dashboard. Now you have certain specification. So you have given those specification, and based on those specification, certain different sellers, different brands phone came as per your requirement. Let's say 2 phone for Samsung, two phone from Apple, 4 phone from some other Chinese company, like that. Now user can choose which he wants based on his budget, based on his technical requirement and other thing. So here no one is deciding. So earlier case, this broker is deciding what based on your request. Here no one is deciding what to purchase or what to think, but there is a centralized place. So on app is one of the example where in cloud market, which is providing this kind of centralized marketplace of cloud market, a cloud kind of thing. But both this particular architecture, centralized broker or centralized market, whatever, both have certain limitations or certain issues. Profit sharing, biasness of broker towards certain service providers, price manipulation, unfair dispute of resolution, central point failure. So all those things are generally any kind of centralized kind of architecture have. So what is our objective then? The central broker and design a decentralized kind of architecture. So this is our target, right? So this is our target. If we remove this person, so if we remove this person and if we do this kind of architecture. So now you can map that what we have discussed with blockchain, and here in this cloud architecture, similar kind of issues arise, right? If you properly think that whatever the concept or whatever the properties the blockchain have, that thing exactly mapping with the issue of what cloud service provider or cloud architecture is suffering, right? So we can go with something like this. So, but the challenges are the decentralized platform for exchange of infrastructure resources must be developed. The system must allow coordination between service provider, where enforcing the FLA. FLA is a federation level agreement without the help of any broker. Cloud functions such as VM placement, VM migration need to be coordinated over the decentralized architecture. Fair ordering of the transaction must be ensured. So our proposed architecture is to delete this person, this kind of architecture, and it can be something like that. And I think you can understand by this time we can straightforward use this kind of technology called blockchain into this kind of to solve the problem of what cloud service, multi-cloud architecture or federation is facing. So what we did in our work, so this work has been published in one of the top conference that is called IEEE Service Computing Conference, which is A grade conference. So this is first of its kind. Before that, no work has been done with this. So we called this work as our name of this proposed model was called Cloud Chain, and it is basically permission blockchain based decentralized exchange for democratic cloud federation. So this is the work. It was published in 2019, first time. Before that, this kind of things was not there, and that conference happened in the Milan, Italy. So what we have in this architecture, basically, I will not explain in detail, but how to map this one, that we will explain. So there are basically two kinds of service provider. One is demanding service provider, another is supplying service provider. So demanding service provider, which is basically demand for the service from other service provider, and supplying service provider is something which is basically supplying the resources based on the demand from other service provider. So I will explain a little bit more on this. For example, you can take example of this particular architecture. Let's say one service request came to this particular service provider, and this particular service provider don't have that resources to be served to this particular user who is asking for the service. Now what he can do, he can seek service from his peer. So here are these and these three are peers of this particular service provider. So what he can do, he can ask help from his peers, and maybe this person have that particular service to be provided. But so what he can do, he can give this service to this particular service provider. Basically, he is connecting to his data center, and ultimately through this particular service provider, this user is getting that service. So here, this is basically demanding service provider, and this is basically supplying service provider. In this way, we have defined the type of service provider in the cloud chain or the proposed architecture. So we have certain components in the cloud chain. There are, so you can see this particular diagram that there are three service provider, 1, 2, and 3. and we have certain things. So if you zoom it, each service provider have few components like request queue, where the service request we will noting, resource bucket, whatever the resources we have, means infrastructure resources we have. We have a scheduler to schedule it. We have a VM manager who will place the VM or initiate the VM. We have a transaction manager. What are the transactions, cost, and everything it will calculate. And finally, it will log into the ledger, the distributed ledger, which have local and global copy too. So as I told, these are the different components and everything has something. So I will not go in detail. So we can offer a new request through this thing. We can modify existing offering. We can query the available resource offerings. We can request to rent the resources. We can grant and reject the resources. So any request. So we can see that whatever the objective and the properties normal cloud federation or multi-cloud architecture have, all these things are intact in this particular proposed model. So I will just briefly explain how things are happening and how we have implemented the logic. So basically, this is your smart contract. So the smart contract is the logic. So how we wrote our smart contract and what the logic behind it, that I will going to explain now. So here you can see that multi-tier application request will come into the resource queue. Now, this request, whatever the request is there, that request can be two types, right? So we have to check what type of request it is. So it can be a local request, it can be a remote request. So for supplying service provider, it can be a remote request. For demanding service provider, it can be a local request. So the local request is for them who is basically requests coming to that particular service provider. So we will check that and we will check this also. So we will check local request or remote request. Then if it is local request, it will check the local resources are available or not. If local resources are available, then we can choose the best offering from them, what are the different pricings and other things, and we can ask VM manager, transaction manager to log that one, execute that one, log into the cloud chain, that is distributed ledger, and we can send for the placement and it will be placed. But if it is remote request, then that will be checked to the other service provider for the best offerings, and that can be a local request for demanding service provider, and it will again ask into the transaction manager, executing that, and it will send for the placement for that particular service provider. That is basically your supplying service provider. So we have implemented this thing in a test bed setup. We have taken 3 hosts, basically, each acting as a cloud connected over the network. We have used Hyperledger Fabric version 1.3.0 that time. And we have set up this particular architecture in our lab. So Hyperledger Fabric have certain things to be set up. So we have designated these C1, C2, and C3 as organization 1, organization 2, and organization 3. We have run these peers into different organizations. We have different cloud orderers. So each organization can run its own orderer as orderer 1, orderer 2, and orderer 3. To create, so we have set up, this one is in our institute LAN. So we have to create a virtual private network to set up that thing. So we used Docker Swarm, using Docker Swarm. So we have created a Swarm overlay network between these three servers. We place these three servers in different verticals, different buildings in our institute to realize the thing more appropriately. So we created that overlay network between these servers using Docker Swarm, and we used chain code. Chain code is basically the smart contract in Hyperledger fabric, whatever the logic I have told. So we wrote chain code in Go language because Hyperledger fabric support a language called Go, which we have written. And finally, we used some BFT protocol. It is one of the consensus protocol in blockchain, private blockchain, permission blockchain. So it is a Byzantine fault tolerant protocol. So we have used that. We use some endorsement policy for supplying and demanding service providers. And we compared our results with centralized kind of system. Here we can see that there are certain numbers we have. So this number you can see so we have basically we have 34 number of multi-tier application requests as an input, and there are 3 cloud C1, C2 and C3 which are receiving 16, 8 and 10 number of requests respectively. So this blue one is basically your centralized kind of placement. So where as the first server is a bigger one, so if all resources has been placed centrally and biased towards the C1 and some to C2, but C3 didn't get any placement of broker-based system or centralized system. But if you see our cloud chain placement, every service provider got some resources or VMs to be placed in their data center or their host. So this green one is your remote placement, and this orange one or yellow one is your local placement. So you can see that as the C3 server's capacity is little less, so he only able to place the local placement, but he don't not able to place or accommodate some local remote placement. So in conclusion, what you can see, cloud chain over federated broker, so it's a decentralized, no central authority. What is the concept of blockchain? So cloud chain not allowed by any single governing body, instead of collaboratively maintained by all the participating CSPs. CSPs means cloud service providers. Removes any central point failure, ensures distributed and democratic control. Transparent. In broker-based system, all communications between cloud service provider and broker remains confidential. In contrast, every transaction and every operations on the cloud chain platform is shared among the CSPs. The process of updation of any information is transparent and based on mutual agreement. Autonomy. In broker-based federation, the request come at the broker. As you know by this time, the broker is in full control of the allocation of the request among the participating CSPs. In cloud chain, the proposed architecture, each CSP functions with a full autonomy in authoritative domain as an individual service provider. It can insource or outsource the resources according to its own policy, means smart contract. Immutable, the distributed ledger of the cloud chain blockchain keeps history of every operations, that is transactions on the exchange. So we are tracking each and every transaction. Each of these operations are accepted, agreed upon the majority of the participating CSPs, that is consensus. So once consensus happened, then only it will be accepted. Otherwise, that particular transaction will be rejected. In case of any dispute, this immutable log can be audited and decision can be taken accordingly. So if any malicious kind of thing happened, then we can go back to the previous log or previous blocks to take that what happened or what was the earlier data. Based on that, we can take any decision. Fairness, autonomous process and resource exchange among the CSPs through cloud chain ensures fair distributions and profit sharing. So biasness kind of problem in centralized system will be tackled here. No single authority can dictate the allocation of resource request among the CSPs, biasness. So fair ordering event further ensures the fairness of the system. So this is our paper. If you want to read, you can read this paper, and thank you. So I will happy to take some questions. If you have anything, please.
Hello participants, is there any question from your side? Hello. Yes, sir.
Yeah.
Thank you for your valuable guidance on the blockchain and in the cloud applications.
Yeah. Hello.
Yes, sir. We have concluded with this session.
A heartfelt thank you to Dr. Saurabh Kanti Addya for sharing your valuable insights today. The participants truly got inspired a lot from today's session. We thank all participants for your engagement. Thank you, Dr. Addya, and all attendees for joining this engrossing session.
Thank you.